In this demo video, we showcase BLOOCK's identity product. We will be able to carry out a visual demonstration flow through our dashboard that allows users to understand the basic concepts of SSI and discover its potential in multiple applications. To start this demo, we will briefly explain self-sovereign identity and its main concepts. Self-sovereign identity enables secure, private, and non-repudiable authentications that can be reused across multiple platforms. An identity can be a person, company, entity, or even a thing. These identities have a unique identifier called DID. The main actors within this authentication flow are issuers, who will provide verifiable credentials to other identities, in this case, the holders. These credentials can be verified by verifiers using mathematical proofs. To continue, let's describe each of them in detail. An issuer makes statements about another identity and issues verifiable credentials to these identities, and for this, third parties must consider it a trustworthy entity. A verifiable credential represents claims made by the issuer about another identity, ensuring their immutability and authenticity. It is interoperable due to standardization. The holder is the identity that receives the verifiable credential issued by the issuer. The holder uses the credentials to prove attributes to multiple verifiers multiple times. Validation proofs are responses to validation requests made by third parties. They can mathematically demonstrate the fulfillment of an attribute without sending any data, thanks to zero-knowledge proofs. Verifiers are third parties that validate the credentials of a holder. They can confirm the validity of the information provided by the issuer to assess the reliability of the issuer. Therefore, the issuer and the verifier must have a relationship of trust. After explaining the general concepts of SSI, we will begin with a practical example using the BLOOCK dashboard to test an end-to-end flow using a university as an issuer, a degree as a verifiable credential, a student and a holder. First of all, we will create an issuer. To create an issuer, we must assign it a name and optionally provide a description. Currently, we can create issuers with identifiers or DIDs of Polygon. In the future, more options will be available.
Next, we will select the transaction interval, which will set up how often our credentials are transacted to the blockchain and obtain proof of their integrity. Finally, we will be able to select an avatar for this issuer. Once this issuer is created, we will be able to visualize various relevant aspects in the details section, such as its unique identifier, associated signing key, and name and description. Next, we will generate a schema. These schemas ensure the reusability of credentials across platforms and services. Users must create a schema, which will ultimately serve as a template for their credentials. These schemas contain the attributes, claims, that your credentials will have. In this example, we'll develop a schema for a university credential awarded to students upon completing specific training. We'll define various attributes to serve as properties of the generated credential. These attributes can take different formats, including string, integer, boolean, datetime, and date. Depending on the schema's requirements, some attributes may be optional while others mandatory. We'll introduce fields such as student name, string, course name, string, graduation date, date, credits earned, integer, valid from, datetime, and university honors roll member, boolean. This way, we can create a template for credentials with various attributes related to educational achievements. After creating the schema used as a template for our credentials, we can access more details about it in the schema details section. Here, we'll find information such as the schema name, ID, and a link to its JSON format on IPFS. Below, we can view the schema's attributes and types. To test the product's end-to-end flow, we'll select a Test Schema section. It's important to highlight that BLOOCK prioritizes user privacy by not directly generating credentials. Instead, it provides clients with self-deployable APIs and libraries, enabling them to independently and securely manage the process. We will add values to the attributes we defined earlier to create our first credential. In this case, the first step will be to add the DID of the holder, the user who will receive and possess this credential. In this example, it would be the student. Next, we will add the issuer that generated this credential, in this case, the one we created earlier, and an expiration date for the credential. These fields are required. Next, we will add the values that each attribute of the credential contains, such as the number of credits earned, the graduation date, the name of the completed course, the student's name, whether they belong to the honor roll or not, and until when this qualification will be valid. Once the form is filled out, we will select Generate QRA. For this demonstration, we will use the Polygon ID wallet to store this credential, although any entity can create its application for this process or even use other data flows depending on their needs. In this case, we will select the button to scan the credential and then add the credential to our wallet. Now we can view its contents in the application. In the video's final section, we'll cover validation queries. These queries set rules for credential attributes to meet the verifier's requirements. They assist validators, like a third-party verifying completed studies, by outlining criteria for attribute values to ensure successful validation. For this example, we will create a query called validate number of credits. To begin, we will select the schema on which we want to create a validation query. Next, we will select the attribute we want to validate, in this case, the number of credits earned, and the type of query we want to create, which will be a condition. Based on the attribute type, in this case, integer, we will select the comparison operator, in this case, greater than, and the value that the attribute must have to be validated, which will be 50 for this example. This way, we specify that for this validation to be successful, the number of credits the attribute must have a value greater than 50. To test this validation query for the credential we created earlier, we'll generate a new QR code for this validation. We'll use our wallet to scan this validation query, allowing us to check if our credential contains a value of more than 50 for the credits earned attribute. As we can see, it has been successfully validated, and all that remains is to approve this action to generate our validation proof. Thank you for joining us on this journey. See you in the next video, and stay tuned for more exciting content.